Okay, so this is going to be our last set of derivatives, just straight derivatives. The first little section we're going to talk about is how to put derivatives in your calculator. So you put your original function in y equals. So my original function is x cubed minus 6 natural log of x times sine of x minus 8. Now I need to make sure that I'm always in radians, okay? And then we're going to do math 8. So quit. Math 8 vars y1 comma x comma, and I'm evaluating it at 2.2. So 2.2. And I should get 10.719. Next one says we want to do the equation of the tangent line at the point 3.6. So what I'm going to do is I'm going to put 2 to the x power minus 4.4 e to the 2x minus 7. And I'm going to quit, and I'm going to go to my table. So we don't have a y value in this case, so 3.6, I put that in my table. I get 6.7516. Now, since I'm doing equation of a tangent line, I'm going to take my derivative in the calculator. So math 8 vars y1 comma x comma, and I'm evaluating it at 3.6. So negative 2.343. So my equation of my tangent line is 6.7516 is negative 2.343 x minus 3.6. Okay, and that's your equation of your tangent line. Now we're going to talk about rates of change. So it says, do we want to prove that this is increasing, decreasing, or not changing at negative 2? So if it's increasing, it's a positive slope. Decreasing, it's negative. Not changing, it's 0. We take our derivative. So it's 8x minus 2. And I'm going to plug in a negative 2. So it comes out to be negative 18. So it's decreasing. Okay. Does v of t ever stop changing? If so, when does it stop? So is the derivative ever equal to 0? So we're going to take our derivative. So we're going to write the bottom, derivative the top, minus write the top, derivative the bottom, all over the bottom squared. So we're going to FOIL out all this good junk. So it's going to be negative 4 minus 3t minus 6 and plus 3t. The 3t's will end up canceling. Yeah, they will end up canceling. So right the bottom, derivative the top, minus right the top, derivative the bottom. Yeah. So you're left with negative 10 all over 4 plus 3t squared. So it will never stop changing. It will always be negative. Okay, so remember that a squared is always positive, so a negative divided by positive will always be a negative. Okay, it says the voltage in a rechargeable battery is given by the function, where t is in days. At what rate is the battery changing after 3 days? Okay, so we're going to use our calculator on this one. So if I'm looking for the rate of change, I'm looking for the derivative. So we're going to look for v prime of 3. We want to use correct units too. Okay, so we're going to put our function in y1. So it should be 3 minus t, 3 minus x, divided by 4x squared minus 2x plus 1. Okay, we're going to quit. We're going to math 8, y1, comma x, comma 3. And so we should get negative 0.0323. okay? And it's going to be volts per day, okay? Voltage is in volts, and your time unit is days. Okay. The population of some insects in a field is given by the function that. At what rate is the population changing at 15 months? So we're going to look for P prime of 15. So we'll put that in there. Let's make sure we're in radians. So 5x plus 9 sine of x minus 3. We're going to mathate this. Bars y1 comma x comma 15. Get negative 1.837. So that's going to be insects per month. Okay, going on to the next page. We'll start talking about accumulations and related rates problems. Okay. So this type of question would show up on free response. Okay, so shoppers enter at a rate of EFT, and they're exiting at a rate of L of T. After 4 hours, what is the net rate of people entering and exiting the store? So what we want to do is E prime of 4 minus L prime of 4. Now, you can put that in the calculator. You can put E in Y1. And you could put L in Y2. Okay. So we're going to do math 8 vars Y1 minus Y2, because we're taking the derivative of both of those, comma x, comma 4, close parentheses. And you should get 28.782. So shoppers per hour. So that means you have a net total of 28 people entering the store per hour, even though some are leaving. Okay. Related rates. So related rates, I wrote some of your geometry formulas down here for you to memorize. So when we go and do related rates, we always took the formula and then took the derivative of the formula after. So that's what we're going to do. So it says that our first example problem, it says air is being pumped into a spherical balloon at a rate of 5 centimeter cube per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeters. Okay, so we're going to be dealing with volume of a sphere. So dV dt is equal to 4 pi r squared dr dt. So we have the rate at which the volume's coming in right here, and we need to get this in terms of our radius. So diameter divided by 2 gives you a radius. Okay, so we do 5 is equal to 4 pi. Your radius is 10 squared, and we're looking for dr dt. Okay, so you can use your calculator, you can do it by hand. So this comes out to be 5 over 400 pi. And I'll put it in parentheses on the bottom. So I get 0.00398. And your units are going to be centimeters per minute, because your radius is a length unit, so it's one-dimensional. Okay, next example. It says a 15-foot ladder is resting against the wall. The bottom is initially 10 feet away from the wall and is pushed towards the wall at a rate of 1/4 feet per second. How fast is the top of the ladder moving up the wall 12 seconds after we start pushing? Okay, So our classic ladder question. Okay, so our 15-foot ladder looks like that. And the bottom is initially 10 feet away from the wall. And it's being pushed towards the wall at a rate of 1/4. We'll call this x. And we'll say dx dt is 1/4. So it's being pushed this way. How fast is the top of the ladder moving up the wall? 12 seconds after we start pushing. We're looking for dy dt. Okay, so 12 seconds later, so we're gonna have a Pythagorean theorem, right? So we're gonna say that x squared plus y squared is equal to z squared. We're going to take the derivative of this. And then we're going to cancel our 2's from every term. Now, our x distance after 12 seconds, so 12 times 1/4 is 3. So this distance right here will not be, it will not be 10. It'll be 3 more, but it's going to be going this way. So if I start at 10 and I move in 3 this way, I'm going to have 7 as my new x. Okay, now we have to do a Pythagorean theorem to get your y. So 15 squared minus 49 square root of that, square root of 176. Okay, that's what you get whenever you do a Pythagorean theorem with the 15, 7, and your y term. Okay, so now what we're going to do is we're going to plug in. dz dt is 0 because the ladder's not expanding. Okay, so your x is 7, dx dt is 1/4. Your y is square root of 176. We're looking for dy dt. And your z is 15 times 0. Okay, solving for dy dt. So we get 7/4 divided by square root of 176. So it should be going up at a rate of 0.1319 feet per second. Okay, and if we want to change this to a negative sign, this would probably make a little more sense because it's losing x distance, so we're going to make it a negative, and then since it's going up the y-axis, you know, it's going up here, it'll be a positive whenever we do our problem. Okay, let's do a couple more, and then that'll be the end of this video. Okay, a tank with water in the shape of a cone is leaking out. My printer didn't print the yellow portion of the graph. Okay, so our tank looks like that. So whenever we do a cone problem, we always set up the initial radius, so it's 5/14. So radius to height is equal to r/h. Now, since we're dealing with a cone, the volume of the cone is 1/3 pi r squared times the height. Now, what we do is we cross multiply over here, and we're going to solve for r. Okay, so we solve for r. And this is always the process usually, because we want to figure out how fast the height is changing. So we need everything in terms of h's. Okay, Now we're going to simplify that out before we take a derivative. So 5 over 14 squared. So I squared this out. I get 25 over 196. Divide that by 3. I get 25 over 588 pi h cubed. Now, when I go take my derivative, I get 75 over 588 pi h squared dh dt. Now, we're going to plug in. So, the tank is, it's taking on water at 2 cubic feet per hour. So, we're going to put 2 here. We want to know how fast is the height changing when the depth of the water is 6 feet. So depth and height are going to be the same thing. And we're going to solve for dh dt. So 2 divided by 75 over 588 divided by pi divided by 36. And dh dt comes out to be 0.1386. And it's going to be feet per hour. Okay. Now, the second part of the question is, what is the rate at which the radius is changing? So what we're going to do is we're going to go over here and we're going to take our derivative to find dr dt. Okay, and we're going to plug in this over here. And you get dr dt is 0.0495 feet per hour. Feet per hour. Okay. The reason I'm adding the next question to your related rate stuff is because I saw it show up on a multiple choice question. So I never really teach this one, so bear with me. So say you have a lamp, a light post, and you're standing and it's going to create a shadow. Okay, so in this type of question, what we do is we're going to call this XP. So that's the distance from the pole, person from the pole. XS is going to be distance to the shadow. And we're going to say that this all is X. Now, we have two similar triangles. So we're going to set up a proportion. We're going to say 5.5 over 12. So 5.5 over 12, so little to big, is equal to x of s over x. Okay? Now, from there, we're going to cross multiply. And the first part of the question is, what rate is the shadow moving from the person when we're 25 feet away from the pole? The 25 feet doesn't even matter in this question. So we want to figure out how fast is the shadow moving. Well, we know what XP is. Okay? XP is going to be 2 feet per second. Because that's the rate at which the person is going. So I need to get this in terms of X's, XP's and XS's. Okay, so 5.5 XP plus XS, because that all makes up X. Okay, so XP and XS make up X. So what we're going to do is we're going to distribute. We're going to combine our like terms. So we get 5.5 XP is equal to, let's see, 12 minus 5.5 is 6.5 xs. And then we're going to take the derivative. Okay, so we get 5.5 xp prime is equal to 6.5 xs prime. Now, we're going to plug in the 2 for xp prime. We're going to solve for xs prime, how fast the shadow's moving. So I get xs prime is equal to 1.6923, and that should be feet per second. Now, if I want to find out how fast, at what rate is the, at what rate is the tip of the shadow moving away from the pole? And at what rate is the tip of the shadow moving away from the person? Okay, so we found, so what this is we found how fast the shadow is going to be moving away from the person. Now, we need to find what x prime is going to be, how fast the shadow is moving away from the pole. Okay, so this is the whole distance from the pole. So we're going to go back and we're going to substitute. So we say x is equal to xp plus xs. And x prime is going to be equal to xp prime plus xs prime. So you just add them together, your rates together. So xp prime is 2, xs prime is 1.6923. So we get x prime is going to be moving at 3.692 feet per second. Now, I did put one of these questions on your homework so you can get another try at them. It's just a little bit confusing. So you need to make sure that you pay attention to what each part's asking. So at what rate is the tip of the shadow moving away from the pole when the person is 25 feet from the pole? Okay, so that's going to be x prime. At what rate is the tip of the shadow moving away from the person? That's going to be xs prime. Okay, it's confusing. I know. I had to look it up. Okay, we're going to stop there, and our next video will be over velocity and acceleration. I didn't want to make this one too long, so I'll come back in a second. Thanks.